Imagine a universe, a mirror reflection of our own, where everything is reversed. Instead of matter, the familiar building block of our existence, there exists antimatter. Antimatter is both alluring and terrifying, a concept ripped from science fiction yet firmly rooted in scientific reality. It is the ethereal twin of matter, identical in every way but opposite in charge. For every particle of matter that makes up you, me, and the world around us, there exists an antiparticle. An electron with its negative charge has a counterpart called a positron, identical in mass but with a positive charge. The concept of antimatter opens up a Pandora's box of questions and possibilities. The meeting of matter and antimatter is not a peaceful affair. When these two opposites collide, they annihilate each other in a burst of pure energy. This annihilation is the most energetic process known to physics, releasing energy with unmatched efficiency. Imagine a tiny amount of matter, just a gram, colliding with an equal amount of antimatter. The energy released in this annihilation would be equivalent to the detonation of millions of tons of TNT. This immense energy release is the reason why antimatter has become a staple of science fiction. The process of annihilation is not just about destruction, it's about the fundamental conversion of matter into energy. Einstein's famous equation, E equals mx squared, encapsulates this relationship. Now let's venture into the realm of speculation. Imagine an antimatter universe, a cosmic mirror image of our own where everything is made of antimatter. Would the laws of physics be the same or would they be reversed? The answer, as far as our current understanding of physics goes, is that the laws of physics would be the same in an antimatter universe. Gravity, for example, would still be an attractive force, pulling antimatter together just as it pulls matter together in our universe. The electromagnetic force responsible for light, electricity, and magnetism would also behave the same way. This means that an antimatter universe wouldn't look all that different from our own. Our exploration of antimatter leads us to a rather unsettling question. What would happen to a human body in an antimatter environment? The answer, unfortunately, is not encouraging. Our bodies, composed of ordinary matter, would react violently and catastrophically with an antimatter environment. Every atom in our body, from the carbon in our DNA to the calcium in our bones, would undergo annihilation upon contact with antimatter. This wouldn't be a gradual process, it would be instantaneous and explosive. The energy released from the annihilation of even a small amount of matter and antimatter is immense. Larger amounts of antimatter would result in even more catastrophic consequences. So, to put it mildly, an antimatter environment is not conducive to human life. Section 5. Strategies for survival, navigating an antimatter environment. While the prospect of surviving in an antimatter universe seems bleak, let's indulge in a bit of scientific imagination. Imagine a universe where every particle of matter is replaced by its antimatter counterpart. The challenges would be immense but not insurmountable. What if we had to find a way to exist in such a hostile environment? The first step would be understanding the fundamental differences between matter and antimatter. What strategies and technologies would be needed to even contemplate such a feat? Advanced research and development would be crucial, focusing on creating materials and technologies that can withstand antimatter interactions. The key to survival in an antimatter universe would be absolute containment. This means developing containment fields that are not only strong but also adaptable to various environmental conditions. We would need to create environments completely isolated from antimatter, impenetrable barriers that prevent even the tiniest of antiparticles from crossing the threshold. These barriers would need to be monitored constantly for any signs of weakness. Think of it as the ultimate hazmat suit, but on a much grander scale, encapsulating entire habitats or even cities. These habitats would need to be self-sustaining, with their own ecosystems and energy sources. These containment fields would need to be incredibly powerful and reliable. They would have to be tested rigorously to ensure they can handle the stresses of an antimatter environment. The slightest breach could spell disaster, leading to a catastrophic annihilation event. Therefore, constant vigilance and maintenance would be essential to prevent any potential breaches. Section 6. Technological Essentials, Tools and Innovations for Antimatter Coexistence. Surviving in an antimatter universe would require a technological leap beyond anything we can currently achieve. We would need to master the manipulation of forces and energies on a scale that borders on science fiction. One essential technology would be the antimatter vacuum. This device would create a region of space completely devoid of both matter and antimatter. Another crucial tool would be the antimatter trap. This device would use powerful magnetic and electric fields to confine antimatter, preventing it from coming into contact with ordinary matter. Antimatter traps would be essential for storing and transporting antimatter. Section 7. Antimatter Propulsion revolutionizing space travel. The immense energy released from matter-antimatter annihilation has captivated the imaginations of scientists and science fiction writers alike. This concept has been a staple in many futuristic narratives, painting a picture of a world where space travel is as common as air travel. Could this incredible power be harnessed to propel spacecraft across the vast distances of space? The potential is there, but the challenges are immense. The answer is a tantalizing, albeit distant, possibility. Scientists are working tirelessly to turn this dream into reality, but it requires overcoming significant technological and scientific hurdles. Antimatter propulsion at its core is based on the idea of controlling the annihilation reaction and directing the resulting energy to produce thrust. This involves sophisticated engineering and precise control mechanisms. In theory, even a tiny amount of antimatter could generate enormous amounts of energy, potentially allowing spacecraft to achieve speeds approaching the speed of light. This could drastically reduce travel time between planets and even star systems. Imagine a spacecraft powered by an antimatter engine, capable of reaching distant star systems in a fraction of the time it would take conventional rockets. This would open up new frontiers for human exploration, and possibly even colonization. Such a technology would revolutionize space exploration, making it feasible to explore and perhaps even settle on planets that are currently beyond our reach. The future of space travel could be closer than we think. Section 8. The Perils of Antimatter. Challenges and Considerations. While the potential of antimatter is undeniably alluring, it's essential to acknowledge the inherent dangers and challenges associated with this enigmatic substance. Antimatter is not a power source to be taken lightly. It demands respect and caution, for its destructive potential is as great as its potential benefits. One of the most significant challenges is containment. As we've discussed, even the slightest breach in containment can lead to catastrophic consequences. Developing containment systems robust enough to reliably contain antimatter for extended periods is a daunting task. Another challenge is the production and storage of antimatter. Currently, we can only produce minuscule amounts of antimatter in laboratories, and storing it is equally difficult. Section 9. The Quest for Antimatter, Unlocking the Secrets of the Cosmos. Despite the challenges and dangers, the quest to understand and harness antimatter continues. Scientists around the world are working tirelessly to unlock the secrets of this enigmatic substance. At CERN, the European Organization for Nuclear Research, scientists use powerful particle accelerators to create and study antimatter. By smashing protons together at near-light speeds, they create tiny amounts of antimatter, which they then trap and study using sophisticated detectors. These experiments are shedding light on the fundamental properties of antimatter. The more we learn about antimatter, the closer we get to unlocking its potential. Section 10. The Future of Antimatter, Possibilities and Speculations. Looking ahead, the future of antimatter is a tapestry woven from both scientific possibilities and speculative wonder. Will we one day master the manipulation of antimatter, harnessing its power for peaceful purposes and unlocking new frontiers in space exploration? Some futurists envision a future where antimatter fuels interstellar spacecraft, allowing us to reach distant star systems. Others imagine antimatter as a potent energy source, providing clean and nearly limitless power for our growing energy needs. However, it's crucial to temper these aspirations with a healthy dose of realism. The challenges of producing, storing, and manipulating antimatter are immense. Section 11. Conclusion: Surviving the Antimatter Realm. Our journey into the realm of antimatter has taken us from the explosive annihilation of matter and antimatter to the speculative possibilities of entire antimatter universes, where the rules of physics as we know them might be completely different. We've explored the technological marvels that might one day allow us to harness its immense power, potentially revolutionizing energy production and space travel. While the prospect of surviving in an antimatter universe remains firmly in the realm of science fiction, it sparks the imagination and drives scientific inquiry. The study of antimatter is a journey of profound scientific significance, offering insights into the very fabric of our universe. It challenges our understanding of the universe, presenting new questions and possibilities. This pursuit pushes the boundaries of our knowledge, encouraging us to think beyond the conventional. It inspires us to explore the unknown with both caution and wonder, reminding us of the vastness and mystery of the cosmos. Perhaps one day, we will unlock the full potential of antimatter, using it to fuel our ambitions of space exploration and beyond. Harnessing its power could open new frontiers, making interstellar travel a reality. But even if that day remains far in the future, the quest to understand antimatter will continue to illuminate the path of scientific discovery. This relentless pursuit of knowledge not only advances our scientific understanding but also fuels our dreams of what might be possible in the vast expanse of space.